So this first part of the lesson is revision of all those things relating to statistics. So task number 1, please can you match these up? You'll be fine to just write down 1A, 2B and so on. So your answers for those are these ones here. 1 matches with F, and then you've got 2 with A, 3 with B, 4 with C, 5 with D and 6 with E. There you go there. Next one, please can you match up each of the words A, B, C and D to one of the 4 diagrams that you can see in each of the corners. Again, you'll be fine to just write down 1A, 2B and so on. So this time you're looking at A matches with 2, so 2 goes with A, 1 goes with B, 4 goes with C, and 3 goes with D. First 2 are the definitions of mutually exclusive and not mutually exclusive. The second 2 are the definitions of independent versus non-independent. It's diagram number 4, which is the not independent one. So think about those suites again. We are not replacing them as we take our second suite. And so the second probabilities change depending on what happened with the first suite. So this time, please can you match up each of the words with each of the 4 equations? And your answers are 1 goes with A, 2 goes with B, but then the other 2 are swapped. Again, we're looking at definitions of independence and mutually exclusive. It's probably worth writing those equations down so that you're really sure and can use those when you need to. Next one, we've got 2 questions here. The question is, can you or should you use a tree diagram or a sample space diagram for each one? So read question 1, then read question 2 and decide what you're going to use and why. So your answers are, for question number 1, you're going to use a tree diagram because the second event depends on the first one. There's that wording in there, when Josie is waiting at the trough. So the second probability depends on what happened first time around. Question number 2, the answer is sample space diagram because we've got no indicated order of events. Hypothesis testing. How many of the 8 things can you remember from that table that you wrote down? Try and fill this in as best you can. Don't worry if you get the order mixed up here. So your answers here are these ones here. Can you give yourself a mark out of 8 for those that you got right? If you separated the state the null hypothesis and state the alternative hypothesis into 2 points, then actually they just go as 1. So you just give yourself 1 point for that. Again, don't worry about the order. Next one then. So we've got an exam question here. Please can you have a go at all of it? So our answers this time. The mean is 13,790 divided by 100 because there were 100 pebbles. The variance is the sum of the squares divided by 100, take away the mean squared. That gives us 240.09. That's the variance, remember. If you wanted standard deviation, which we don't, if you did want standard deviation, you'd then have to do that extra step of square rooting that. Part 2, we removed one of the stones, which was the biggest one, so we've now got 99 pebbles. So we amend the data. I've taken away 260 from the sum of the masses. That gives me a new figure of 13,530. And I've taken away 260 squared from all of the masses squared. So I've got new figures there. I'm now going to do new calculations. So the new mean it comes out pretty much as 137. It's that number divided by 99. And then the new variance is the sum of the squareds divided by 99, take away our new mean squared, which gives us a surprisingly lower 90.59. Does it make sense that it's that much lower? Well, I guess we were taking away the biggest one, and so we have then made the variance much smaller. So I guess it does make sense. Here's an exam question on binomial distribution. So your answers are: state an assumption that's to be made about students being late. The probability should be constant and it should be independent. However, this may not be the case, as students are likely to arrive together. If one is late, then another one's going to be late, and so on. Maybe the previous class finished late, something like that. Part B, find a property that in a class of 23 students will be late. It says fully justify your answer. So by fully justify, I'm tempted to use the formula, although I accept, and in fact I did, just use the calculator to work this out. I think on exam day, if I wanted to make sure that I got all of that, I would write the formula down and then also quote the answer as I've done there from the calculator. Part C, we're looking at the probability of more than 4 students being late. So I've done 1 minus that. So the probability of less than or equal to 4 students being late is 0.9974. So the probability of more than 4 students being late is 1 minus that, which gives us 0.00257. Be really careful with your more than 4, more than or equal to 4, and so on. Now we've got a question on probability distributions. Can you have a go at these two, please? And your answers are: find K. So if we put x is equal to 4, that gives us 16 take away 9, which gives us 7k. If we put x equal to 5, we've got 25 take away 9, which gives us 16k. And if we put x equal to 6, 36 take away 9 gives us 27k. So we know that 50k, all of those must add up to 1, so k must be 0.002. Sorry, 0.02. The probability distribution then, feeding that back in and writing down our table, gives us x values of 4, 5, or 6 with probabilities of those ones there. It is well worth checking when you do that, do your probabilities add up to 1, which of course they should do. If they don't, you know you've made a mistake, go back and look at it. So an exam question on hypothesis testing. Can you have a go at this one, please? I do suggest you use the table to help you. So define the variable. The variable is P, the probability of germinating. The null hypothesis is that probability remains as 0.7. The alternate hypothesis is because we were looking at whether they're more likely, so its probability is greater than 0.7. The significance level is 5%, and because we were just looking at whether they're more likely, that means that it's one-tailed. So now, crunching the data through, the probability that x is greater than or equal to 18, what was the chance of that happening anyway? It's 3.5%. How does that compare to our significance level? Well, that's less than the significance level. So there was quite a small chance of that happening if the probability remained at 0.7 or 70%. So therefore, because that probability is so small, I'm going to reject the null hypothesis and accept the alternate one, that there is evidence to suggest that the new seeds are more likely to germinate. So P is greater than 0.7. Okay, this time it's hypothesis testing about finding the critical region. Can you have a go at this one, please? Read the question quite carefully, apart from the silly stuff about Tom Cruise. We've got the probability that he hits it with one dart is 1 dart with every 5. So probability that equals 0.2. He is going to throw 50 darts, so n is equal to 50. We're looking for an improvement, so therefore we're looking for one tail. And the significance level, I'm thinking about that curve now, I'm looking at actually 99% in one end, 1% in the other end. Okay, so now I've just gone on my calculator and I'm testing numbers out and I'm looking for 99%. It turned out that when I put 16 in, So probability that x is less than or equal to 16 is 0.98. Probability that x is less than or equal to 17 is 0.99, which are in either side of 99%. So from this, we can say that the least number of darts required for him to have demonstrated an improvement is 17. Now that number, to be honest, you might be thinking is a little bit small out of 50. But well, what was the expected value? The expected value, he was getting 1 dart in every 5. So if we're doing it out of 50, the expected value is 10. So actually 17 is quite a lot higher than the expected value of 10. So yeah, that kind of fits with our 99% or our 1% significance level. Okay, what next then? You're going to do your statistics topic test. This is going to take you the rest of the time here. We've made it online, just like your homeworks are, but you only get 1 attempt at this. There's the link there. Read the questions carefully. Take care with it. Good luck.